Welcome to Diamonds Are a Geologist's Best Friend. This quote from Sir William Bragg is exactly the case for this presentation. First, let's find where diamond deposits occur in various parts of the world. I believe that geologists who are not specialists in diamond deposits would be surprised just how widespread diamond deposits are. We will be focusing our attention on Africa, especially the southern part of Africa. The scientific model that we are developing in this presentation will allow us to predict where to find more diamond deposits. This whole presentation revolves around a very simple question: why do diamond deposits occur where they do? I promise by the end of this presentation you will have an answer to that question. It was Dr. George E.P. Box who drew our attention to the fact that all models are wrong, but some are useful. A quote from Dr. Box: "It has to be remembered that a subject as concrete and mathematically satisfying as experimental design, that is, a model, is actually embedded in a morass of uncertainty due to the possibilities that the experimenter might choose the wrong variables, might explore the wrong region, and exploration geologists are well aware of that possibility, or, what's more important in respect to our model, or might use scaling that was inappropriate." Even though we are presenting several different scales of geology maps for South Africa, the most important thing to appreciate is what is or is not appropriate scaling. I believe for most geologists this is where scaling begins. You're out in the field, you pick up a rock, and you go, yes, nice size, fits nicely into my hand. However, you have gone a bit upscale because that hand specimen, a few centimeters across, has come from an outcrop that is meters across. And the next stage is regional geological mapping, that is, rock type variation over kilometers. And ultimately you end up with a geological map, rock type variation over an entire country. The most important thing to realize in respect to this 300-kilometer diameter circle is that it is a small feature when it comes to scaling and understanding why diamond deposits are where they are. That circle, of course, includes the multiple gold deposits all on the edge of the Witwatersrand basin. The various gold fields in the Witwatersrand basin, shown here, constitute 20% of the total amount of gold ever taken from the earth. Note that the Redefort dome is the very center of a recognized complex meteor impact. This is such a good example of scaling and why it is so important. Without an appropriate scaling device, one cannot appreciate what this photo represents. We can appreciate what this photo represents only after we realize that the two blue arrows are pointing at two people walking along the floor of Death Valley, California, USA. So in this particular case, rather inappropriately, we are using people as our scaling device. Scaling, complexity, and emergence. I believe that every geologist who has worked on a mineral deposit will agree that they are indeed complex systems. If emergent properties are the single most distinguishing feature of a complex system, exactly what are they? Professor John Holland, the author of the book Emergence, From Chaos to Order, was the person who actually coined the phrase emergence. I contacted Professor Holland and explained the importance of his book to mineral deposits. This sentence was in his response, quote, "It certainly fits my intuition that mineral deposits would be an emergent phenomenon, but you've given the intuition legs." And as Alwyn Scott in his book Nonlinear Science says, perhaps the most important implication of the new paradigm is that coherent structures must be treated as independent dynamic entities. Each emergent structure has its own regularities of propagation and interaction, which must be respected. And part of that independent dynamic entity that is critical to understanding the processes is an appropriate scaling. And as mentioned previously by Dr. Box, one of the failures, one of the things that might cause our model to fail, is an inappropriate use of scale. I believe the best way to show an appropriate scale of our current inquiry is to show a few inappropriate scales. A totally inappropriate scaling that could be used is astronomical units, where one astronomical unit represents 150 million kilometers. Totally inappropriate. And going to the other extreme, we could use microns for scaling. It becomes obvious from this diagram that using 70 microns, the diameter of a human hair, is totally inappropriate scaling for measuring anything on or in the Earth. Perfit et al. 2012, in their paper titled Multiscale Investigation of the African Lithosphere, use appropriate scales for our model, for our investigation. The measured gravity anomalism for all of Africa. The computed Bouguer gravity anomalism for all of Africa. When the measured gravity anomalism has the computed Bouguer anomalism subtracted, the residual gravity anomalism is revealed. And there are two components to the residual gravity anomalism. They are a crustal component and a mantle component. The residual gravity anomalism. One can see from the quote from Perfit's paper that they believe the difference between their crustal model and the real African crust resulted in the various gravity anomalies we can see here. However, the most obvious feature of this short wavelength gravity anomalism is the incredible regularity of that anomalism, of that gravity high anomalism. It seems very unlikely that such regularity could arise from rock or crustal differences. The differences are much more likely to arise from variations in the mantle. In fact, it will be shown in the next few slides by analyzing the data presented in this map that each of these gravity highs is a major plume. Here we have connected each of the gravity highs with proximal gravity highs. This is referred to as a Delaunay tessellation or triangulation. Those connections between gravity highs are labeled so they can be measured. Here we have recorded the distances in kilometers between the centers of various gravity highs. The distance between gravity highs is essentially identical between mean and median. This means that this is a normal distribution or a bell-shaped curve. Worldwide, there is a discontinuity in the mantle at an average depth of 660 kilometers. However, we will show that this discontinuity in Africa is at a depth of 626 kilometers. We will do this using the data provided previously for the distance between gravity highs. Even though the mean is 660 kilometers to this discontinuity, there is a range of values when the entire world is taken into consideration. That range is 590 to 690 kilometers. Short wavelength gravity anomalism compared to mantle plumes within a superplume. Here we can see the various plumes recognized by Shear and Schmale in 2001 within the African Atlantic superplume. A detail of the previous map focusing totally on Africa. A comparison of the predicted locations more than 20 years ago by Shear and Schmale with those predicted using gravity data in the current analysis. Rayleigh-Bénard convection, discontinuities in the mantle, and diamond deposits. What is Rayleigh-Bénard convection? This is Rayleigh-Bénard convection forming a four-sided cell. If the plumes, the very centers of the cells, were closer together, the cell shape would be hexagonal in cross-section. The white outlined area is created by a Voronoi tessellation. This tessellation is created by having the distances between gravity highs, as indicated by our red lines, and dividing those lines in half with the white lines. This allows us to determine the perimeter of the Rayleigh-Bénard convection cell. Please note that this cell is hexagonal in cross-section and approximately 1,500 kilometers in diameter. Why aspect ratio 2 is important in Rayleigh-Bénard convection. The importance of this aspect ratio in Rayleigh-Bénard convection is critical to us understanding the locations of diamond deposits. The section 4.2.3 in the reference shown below will go into aspect ratio 2 much more comprehensively. This simulation of Rayleigh-Bénard convection illustrates what is meant by aspect ratio 2. So note that the individual cell is always twice as wide as it is deep. The straightforward relationship between the depth of the convecting layer and the horizontal dimension of the convection cell, that is, its wavelength, is well established by both numerical and laboratory simulations of convection in the Earth's mantle. As Anderson and Mantle show in their respective books, the most efficient way for the Earth to dissipate its internal thermal energy, that is heat, is through convection cells that have a lateral dimension twice the depth of the convecting layer, that is, aspect ratio 2. Why radial patterns are important. So what is the evidence that these radial patterns arise from a plume? Rayleigh, 1995, in his epic tome Geology of the Earth, showed that the capacity of the mantle to flow over long time scales of 10,000 to 100,000 years in response to thermally or mechanically induced stresses makes convection central to any analysis of the dynamics, whether chemical or geological, evolution of the Earth. And temperature has a central role in geodynamics. It strongly controls the rheology of the Earth. Those radial patterns are a consequence of mantle convection. This is a plan view of Rayleigh-Bénard convection at a Rayleigh number currently considered appropriate for the mantle. The gray and black radial zones are hot material that is ascending, rising towards the surface. The white zones are cool material moving from the surface into the convecting layer. Here we can see that the individual convecting cell can be 3, 4, 5, 6-sided. The ideal would be hexagonal, 6-sided. However, the real world is more like the convection plan we can see here. The circular black areas at the center of the dark gray radial zones are plumes, which are mentioned often in the geological literature. The plume in a cell is where you have the greatest amount of heat present for the greatest length of time. Here is both a plan view and a cross-sectional view of Rayleigh-Bénard convection. Presented here is also the equation for the Rayleigh number. This is a dimensionless number that indicates the transition from conduction to convection. Evidence will be presented showing that the hot radial patterns have been imprinted into the crust from the underlying mantle. And like paleontology and paleobotany, that is the fossil remains of animals and plants, these are fossil heat patterns or paleothermal patterns. The relationships between discontinuities in the mantle, Rayleigh-Bénard convection, and spherical harmonics. Weenik Mines, a Dutch geophysicist, discovered a possible correlation between the topography of the Earth and mantle currents. He found that the Rayleigh number of the mantle currents depends only on the order of the spherical harmonic. This is illustrated graphically in the next slide. The discovery by Weenik Mines of this root mean square of elevation relationship to the spherical harmonic order of the Earth has far-reaching implications in respect to understanding whole Earth process, all the processes in the Earth, and it assists us in understanding why diamond deposits are where they are. The red dashed line is hyperbolic and shows the relationship between root mean square of elevation and spherical harmonic order, except for the first 5 harmonics. The breakdown in this hyperbolic relationship happens because of the strength of materials. What this means, as the topographic feature becomes more laterally extended, that is, becomes wider, eventually the rocks lack the ability for the elevation to maintain a hyperbolic relationship. The most important takeaway from this graph is the relationship between harmonics and the various peaks along the curve. For instance, the peak at 10, 14, 17, 21. Keep those in mind as we go on to the next couple of slides. Weenik Mines noted just how remarkably regular this hyperbolic curve is. This regularity showed him that there must be a physical cause behind it. The evidence presented in the next few slides, the next few tables, will show that the speculations, the realizations by Weenik Mines almost 100 years ago are valid. The various spherical harmonic orders mentioned previously, which are peaks along the hyperbolic curve, are shown here in red. A harmonic is a wave or signal whose frequency is an integral, that is, a whole number multiple of the frequency of the same reference signal or wave. By definition, a spherical harmonic is just that simple. It is a wave along a sphere. To illustrate this point, let's look at spherical harmonic 10. The wavelength would be 4,000 kilometers because the Earth is 40,000 kilometers in circumference. And as Weenik Mines concluded from his work in gravity, that wavelength represented the lateral dimension of a Rayleigh-Bénard convection cell. And being aware of aspect ratio 2, we know that a 4,000 kilometer Rayleigh-Bénard convection cell, the diameter of the cell being 4,000 kilometers, the depth of the cell would be 2,000 kilometers. So thinking three-dimensionally, multiple contiguous 4,000 kilometer diameter convection cells would form a discontinuity at the bottom of those cells at 2,000 kilometers. So let's now compare the calculated depths to discontinuities with the known depths of discontinuities determined by seismic surveys. For instance, at harmonic 10, the 2,000 kilometer calculated depth to the discontinuity compares with the known depth of discontinuity, the blue column, of 2,100 kilometers. Another example, spherical harmonic 7. Aspect ratio calculated depth 2,857 kilometers. Known depth to discontinuity from seismic 2,890. As an aside, the 7th spherical harmonic is also the core mantle boundary. The blue highlighted row at the 30th harmonic is the discontinuity mentioned previously for all of Africa. However, that discontinuity for the whole of Africa on average is 626 kilometers. As will be shown later in this presentation, plumes from much greater depths inside the mantle, even at the core mantle boundary, can coincide with more shallow plumes from discontinuities. These calculations show a direct correlation of spherical harmonics, Rayleigh Bénard convection in the mantle, discontinuities in the mantle, and the Earth's topography. Gravity anomalism and ancient meteor impacts. It was shown previously that the major gold deposits in the Witwatersrand Basin occur along the outer edge, the circumference, of an ancient meteor impact. We will be showing that diamond deposits also occur along the circumference, the outer edge, of ancient meteor impacts. Dentith and Mudge, 2014, in their book Geophysics for the Mineral Exploration Geoscientist, presents us with a very useful technique when analyzing geophysical data. They note that texture is the pattern created by short wavelength variation in tone. The nature of a particular texture can be difficult to quantify, but qualitative descriptions such as rippled and granular adequately describe textural characteristics for geophysical purposes. In the next few slides, change in texture will be used to show the presence of a subsurface structure. This gravity map of the Republic of South Africa will be the data set that we are analyzing. In respect to texture, one can see that it is quite obvious where there is a change in texture as indicated by the red arrows. The South African topography. The subsurface feature is circular. This circular feature is the proposed meteor impact site. In the next few slides, we will be using free air gravity anomalism to reveal even grander scale features, so it's grand scale scaling. The next few slides will reveal the presence of a 1,400 kilometer diameter structure in South Africa. We can see by combining the two data sets what was a proposed meteor impact site in South Africa is probably a proposed inner ring of a complex meteor impact. Seismic shear wave velocity anomalism in South Africa. Seismic shear wave velocity is also a measure of temperature. The slower the velocity, the hotter the rocks. The X-site is proximal to the core mantle boundary and the hottest part of this plume. The next few slides will show the Z, Y, X surface locations from the plumes in the mantle. The Y location originating at a depth of 1,500 kilometers, and the X location originating from a depth of 2,500 kilometers near the core mantle boundary. Here we can see that two very distinctive data sets point at the same location in South Africa. The gravity data shows there is an excess of mass, an extreme excess of mass at this location, and the seismic data shows that it is a hotspot. As we mentioned in the previous slide, the plume, the proposed plume, has its origin in the core mantle boundary. A search of Google Scholar will show that there are many publications relating the core mantle boundary with the origin of kimberlites, diamond-bearing kimberlites. The radial distribution of diamond-bearing kimberlites. Shishel and Smale, 2001, in their article Deep Mantle Plumes and Ore Deposits, mentions that diamonds in kimberlites are connected with mantle plumes. This is the known distribution of kimberlites in southern Africa. There are many such maps available. This one selected for its simplicity, merely a black and white image where patterns are obvious. This shows an obvious radial distribution of the kimberlites in South Africa. Of course, it is possible to draw the lines connecting other kimberlite deposits. The center of the radial distribution of kimberlites. The following movie shows the relationship of the seismic gravity plume and the kimberlite diamond deposits of South Africa. This shows that the yellow circle representing the center of our radial distribution of kimberlite deposits coincides exactly with the proposed plume. The following movie shows the spatial relationship of the plume, the diamond-bearing kimberlites, and an ancient meteor impact. The first thing to observe is that the center of the plume is contiguous to the proposed meteor impact. Research by the author has found that this is the case for giant world-class metal deposits. They are always contiguous to a proposed meteor impact, as well as the world's giant oil pools, again contiguous to a meteor impact. The second thing to observe is that the Premier diamond mine and the Letsing diamond mine, both of which have produced the largest diamonds in the world, are both located on the edge of the proposed meteor impact. The Cullinan diamond came from the Premier mine. It is the largest diamond ever mined. The Letsing Icon diamond, at 439 carats, was one of 15 world-class diamonds that came from this mine. Conclusions and contributions. Scaling is critical to understanding the origin of diamond deposits. Gravity data is especially useful in grand-scale scaling. Gravity data reveals the presence of ancient meteor impacts. Rayleigh-Bénard convection and discontinuities in the mantle are correlative. Spherical harmonics and discontinuities in the mantle are correlative. Gravity and seismic shear wave anomalism are coincident in South Africa and define a plume. The plume originates at a depth of 2,500 kilometers near the core mantle boundary. Diamond-bearing kimberlites are centered on and radially distributed on that plume. The mantle plume is proximal to an ancient meteor impact. And finally, the largest diamonds occur where a radial arm of a plume coincides with the circumference of an ancient meteor impact. So diamonds are far more useful than jewelry fans would lead us to believe. As Professor Pearson explains, quote, "We use diamonds as scientific windows into the deep earth. They give a unique picture of parts of the earth that would otherwise be impossible to access." So, in the truest sense, diamonds are a geologist's best friend.